So what in the world do cutting-edge AI coding assistants and ancient legal texts have in common? On the surface, you'd think absolutely nothing. I mean, one is all about silicon and syntax, the other is about scripture and deep, deep meaning. But what if I told you they're both tackling the exact same fundamental challenge? How do you create a truly intelligent, structured system of rules? You know, way back in 1978, the computer science legend Edsel Dijkstra said something that really became the bedrock of programming. He basically said that strict, formal languages aren't a pain, they're a privilege. They're what give us the power to build these incredibly complex and reliable systems we have today. But here's the twist. For decades, we've been focused on teaching us, the humans, to speak the formal language of machines. The new frontier, the really hard problem, is teaching machines to understand our messy, nuanced, and, frankly, often contradictory human language. And that is a whole different ballgame. So here's our game plan. First, we'll look at the AI that's writing code as we speak. Then, we're going to hit the brakes and talk about the limits of these tools. That's going to lead us to a pretty surprising place, an ancient code for logical debate. From there, we'll see how researchers are actually trying to teach an AI to argue, and finally, we'll ask the big question: what does this all mean for the future of reasoning itself? All right, let's dive in. First up, the new kid on the team. AI coding assistants have gone from this kind of niche idea to a daily driver tool for millions of developers, and it's happened incredibly fast.
We're not just talking about one tool either. A whole ecosystem has popped up. You've got the heavy hitters like GitHub Copilot, which basically lives inside a developer's editor, suggesting code, chatting about problems. It's a huge deal. But then you have specialists, too. Things like Cursor for really advanced work, Bolt.new for whipping up web apps super fast, or JetBrains AI, which plugs right into their popular tools. But they all share the same basic goal: make programming faster.
So how does it all work? Well, under the hood, a developer just asks a question in plain English, right? Something like, hey, create a function that sorts a list of names alphabetically. The model takes that request, breaks it down, and translates it into perfectly structured, functional code. It's this incredible feat of pattern matching, really, trained on just a mind-boggling amount of open-source software.
So these tools are obviously super useful for productivity. They write code, they fix bugs, they can even write tests for you. But their very power brings up a much deeper question. Are they just mimicking, or are they actually thinking?
Yeah. I mean, are they just incredibly sophisticated parrots, repeating and remixing the billions of lines of code they've seen before? Or is there something else going on? Do they have any genuine comprehension of the logic they're putting together? This question, right here, is really the heart of the next big challenge for AI.
This all boils down to the huge difference between syntax and semantics. Syntax is just the rules, the grammar, what the code looks like. In our current AIs, they are absolute masters of syntax. They can write perfect code because they've memorized all the patterns. But semantics? That's about the meaning. It's the logic, the intent, the why behind the code. And for now, that's still the human element in the equation.
So, if you wanted to push past just checking grammar and really truly test an AI's ability to reason, you wouldn't give it a coding problem. No, you'd need a system that's built on layers and layers of debate, interpretation, and pure, raw logic that's been battled over for centuries. And that's where, believe it or not, the Talmud comes in. Now, for our purposes, let's look at it not as a religious text, but as a unique data set of human reasoning. As one study, the Talmud as it exists, points out, this isn't just a rulebook, it's a massive record of centuries of debate. It doesn't just list the winning arguments, it carefully records the losing ones too. Why? So that if someone comes along generations later and makes that same flawed point, it can be identified. The text itself formally categorizes more than 20 distinct types of logical discourse. Things like questions, answers, contradictions, and proofs. It's a code for argumentation, refined over millennia.
So, what if you could teach an AI to navigate that system? Well, an incredibly ambitious group of researchers is trying to do just that. Their project is called the Quantic Programming AI Language Project, or QPAL for short.
What the QPAL project is doing is basically building a Rosetta Stone for logic. They're systematically translating these ancient rules of interpretation into a formal language that an AI can actually process.
So a specific type of argument, like in if this is true, then that is definitely true kind of logic, gets its own code word and math symbol. A counterargument or a refutation gets tagged with a not symbol. They are literally building a bridge from ancient debate to modern AI.
So how does the AI actually argue using this codex? It uses a process called forward chaining. Think of it like this. It starts with a fact it knows is true. Let's say action A is allowed. The system then scans for a rule, like that logic we just saw, that says, well, if A is allowed, then B must be allowed too. It applies that rule, adds B is allowed to its list of truths, and then starts the whole cycle over again, building a chain of solid conclusions. It's literally learning to build an argument, step by logical step.
Now here's what's so fascinating. The project's own ethical design is inspired by the Talmud structure. It's being built with principles like total transparency, where every single logical step has to be explainable. It has foundational, non-negotiable ethics baked in, but also, and this is key, the ability to adapt and debate. It can refine its own rules, just like the sages did for centuries.
This all brings us to the biggest question, right? Why does any of this matter? Why pour all this effort into teaching a brand new AI how to think about an ancient text? Well, the answer could really change the future of artificial intelligence.
What we're witnessing here is a potential leap from an AI that is a master of syntax to one that can actually begin to grasp semantics. That's the difference between a tool that just follows our instructions and a partner that can genuinely reason right alongside us.
And that leaves us with one final, kind of profound thought to chew on. For thousands of years, humans have studied these texts to understand the quirks and nuances of our own logic. If we succeed in teaching an AI to master the same art of argument, what will it end up teaching us? What new patterns, new connections, or maybe even what new flaws might it discover in the way we think? Maybe the ultimate goal isn't just about building a smarter machine, but about holding up a completely new kind of mirror to the human mind.